Hello. In this video, we're going to take a look at Azure Managed Application with an Azure Kubernetes AKS cluster deployed as part of that application, as well as deployment time role assignments to managed identities defined in that managed application. In the previous videos, we looked at a simple Hello World Azure Managed Application, with this example being somewhat more complex. So prior to diving into the specifics, an important point to call out is Azure Managed Application today that's published in Azure Marketplace by default does not allow for a Kubernetes cluster to be included as one of its resources. And it requires a special exception. Therefore, I would recommend if you're working with a Microsoft engineer to double check with them if in your specific situation, your managed application can have an AKS cluster as part of that or not. It's good to double check before you spend time developing that solution. But in this video, we'll assume that you can include it, and we'll talk through some of the limitations that exist today and how they potentially will be removed in the future. So let's dive in. Before we talk about the managed application, including AKS, let's just talk about AKS itself. So in this example, I have a resource group called AV-AKS1. Inside of it, there is a Kubernetes server cluster. You can see that in this resource is just a resource representing the cluster itself, but it does not contain the virtual machine scale sets, the load balancers, the public IPs, the other things that constitute this cluster. Where do these resources live? Well, they live in the second resource group that gets created every time a Kubernetes cluster is deployed, called MC by convention usually _ cluster name, resource group name, region. What's inside of that resource group? Inside of it are the constituent parts of the Kubernetes cluster. Okay, and what happens is when a Kubernetes cluster is deployed, it automatically creates this resource group. Its name can be changed, but by default, at deployment time, but by default, it has the following name. So let's look into how the Azure Managed Application with its resource groups and the Kubernetes cluster with its resource groups kind of fit together and what makes it a little more complex. Okay, so let's say we have a resource group, some resource group that we had before, and inside of it, we deploy Azure Managed Application resource. So this is going to be our resource group 1. Okay. Then let's say we have, this creates a managed resource group for the managed application. And let's say this resource group will be called managed resource group. And inside of it, it will create an AKS cluster resource and maybe a VM and maybe storage. Okay. Now, so this is the resource group that's the MRG is the managed resource group. But AKS cluster, if you remember, will create its own resource group. So it will create another resource group that will be called AKS Resource Group, but really sometimes it has the name MC underneath it. And this is where the VM scale set will be, where the public IPs will be, the load balancers will be, etc. So what is important to note is that the permission from the publisher, right, will be available to this resource group because that's the managed resource group. Will it be available to this resource group? Well, the answer is today, the publisher will also be able to access this resource group, just like they can access this one, because there is a managed by property that's kind of getting inherited since this resource group is created by resource inside of this one. What about the customer? So for the customer themselves, so the customer will have read-only access here by default, if you remember. The publisher has full access. Will the customer have access to this resource group? They will have read access to this resource group, but today, unfortunately, they also have the right or basically the full access to this second resource group because the deny permission there is no deny permission, is not applied to this resource group. So as you can see, the challenge with an AKS inside of a Azure Managed Application is that the AKS resource group right here, the customer has full access to, so the customer could potentially, delete some resources here and break the managed application that relies on the AKS cluster, right? That relies on this cluster. And if the customer deletes the resources, they can basically break the AKS cluster and break the managed application. So as long as you're aware of that potential, that the customer today is not locked away through the deny assignment is missing, the customer can go to this resource group and make some changes there. That is the one of the limitations that exists today. Hopefully that makes sense. So what will happen in the future when some point in future, let's say this is fixed and works properly, and there is a deny assignment on the AKS resource group, what will happen to the publisher and the customer? Well, when this happens, if this happens in the future, the customer will then have read access only, because then now the deny assignment will be there, let's say in the future, to this resource group. The customer will have only read access, just like they have only read access here, and the publisher will have read and write access to both resource groups. So the fix to the deny will not deny the customer access to this. It would deny the publisher access to it, only the customer. So things at some point in the future may be better. But today, be aware, if you're putting an AKS inside of a managed application, the customer is not locked from accessing those resources, stopping the VMs and the VM scale sets or deleting the public IP. You would need to explain to the customer that the offer would not be valid if they do that. You will have access, but so they will they to this AKS resource group today. So hopefully this explains it fully, and now we can dive into some of the templates required for building this. Okay, so now that we understand what are the various resource groups that get created and their interconnection, let's take a look at an ARM template that we can use to play with this. So I will link to this repo somewhere with the video. It shows basically some commands and some examples, very simple, of creating a managed application with AKS and managed identity. And inside of the subfolder, we describe how to create deployment time, user identity, etc. So I'm not going to read what describes here. You can read it later, but we're going to look at the code that's located here and walk through the code to understand it a little bit, and then do the deployment, create a package, put it in, and see how things fit together. So we'll walk through it in that way. So inside, I have that code right here. So let's take a quick look. We'll start from the UI definition. In the UI definition, we will have a basics blade in which we will have very simple settings. We will say that we need to make sure person who is deploying it needs to have ability to assign role definitions because we will be assigning some roles. We will need access to these resource providers, and we will need the resource type of managed cluster available in a location where this deployment will go. In a basics blade, we will just have an AKS cluster name with some allowed characters, node size selector with some defaults, and also node count slider selector, okay? Great. Then we will have a step called managed identity settings. And inside of it, we will have a control called managed identity selector. We'll tell it that we want always to select a system assigned identity for our managed application. And we'll pass out outputs from here, the location, the AKS name, the node size, and the managed identity. How do I know to do this, and how do I know to include that? I'll show you right now where to look at the documentation. So in the documentation, we have a section called Azure Managed Application with Managed Identity. It's long, but it will describe how to do that. This is where I copied some of the snippets of code. It will add this type of blade. This will be selected and disabled this selection. Why do we need this? We need this because in the future videos, we'll look into how to get token on behalf of a managed application. So I wanted to include it right off the bat, so it's there. And basically the way this create UI definition works is we pass the output, this managed application identity output to this properly named managed identity output, and we don't need to have a something in the template with that name. Notice it doesn't exist in this template because this is not the template that gets deployed directly. A managed application deploys itself, and that managed identity is passed to it, basically. This managed identity is passed to the managed application. This is what's inside of the managed application. So let's take a quick look at what is inside of this template. Location, name, node size, node count, cross-tenant, true or false. By default, it's true. This is, you will see, it's a manual flag for local testing, as I will explain as we go. We basically have some variables. And some of these role definition IDs that we will need later for an owner, well-known GUID, for a managed identity operator, well-known GUID, for a virtual machine contributor, a well-known GUID. Those you can find online in our description of different well-known GUIDs. Then we have a resource, and there are some comments added here just to make it simpler. This is the resource we need for a managed application to publish in a portal. It has this attribution tracking GUID. We talked about it in previous videos. Then we are going to have a little snippet of code here that says, hey, create for me a user assigned identity and give it a name. So the name of the user assigned identity is constructed over here. It will just have, AKS cluster name dash identity. Okay. Then we're going to, in the same template, say, take this identity and assign to this identity owner permission right here to this identity right here. Okay, after this identity is created, service principal is the type, add the scope of the resource group, and this is the delegated managed identity resource ID property, an important property, where we say if it is cross-tenant, which is by default is always true, then be putting the resource ID of that managed identity here. This is a not yet well documented flag, and it requires this version of the API. Documentation will probably be updated in the future to describe it more, but for now, it is important to have it here for things we will see, for assigning identities across tenant, because managed application assignments are happening cross-tenant. Then we have a log analytics workspace defined, where we're going to store the AKS monitoring logs. Then the actual AKS cluster. The main things to keep in mind here, we're telling to deploy this AKS cluster with a system assigned identity and custom named node resource group. Remember, we mentioned that by default it has the MC underscore name. If I omit this line, node resource group, the name of the resource group where the nodes are will be MC underscore. But that is hard to use because we'll need to know this name to be able to assign some permissions later in the template. So I am defining the name here explicitly. So how am I creating the name? I'm creating, you may need to do something similar, but maybe a little bit more uniqueness added to it. But right now I'm taking the resource group name and adding AKSRG to it, like in that drawing that we looked here, basically, AKSRG suffix there, okay? So we're telling the nodes to go there. We have one agent pool, okay? And we are doing nothing special here, just enabling the log analytics to send logs there. Now, this is where it gets a little bit more interesting. Let's scroll down in the template to the place where we have a VM created, and we'll come back to this section. So in the managed resource group, we will have the AKS cluster like we defined here, the log analytics workspace. And let's scroll down a little bit and see what else. We're going to also create ourselves an ADLS Gen 2 storage account. We're going to create ourselves a public IP, a network security group allowing port 22 SSH access right there. And we're going to create a virtual network with a simple, address space. And then we're going to create a network interface inside of that virtual network with the right network security group, and then a virtual machine. And a virtual machine will deploy after the cluster is created on purpose. We'll see we need that little delay. And a virtual machine, importantly, will have the identity assigned to it based on the identity we defined above, user assigned identity that we created above in the managed resource group. So this virtual machine will have an identity assigned to it from the beginning. It will be Ubuntu, and it will have the network interface and a US profile with no password, only SSH key authentication. And the output of the template will be the managed identity name, the resource group, the managed resource group ID. That's the context of this deployment. This template runs in the context of the managed resource group and AKS cluster name. Now let's scroll up a tiny bit and see what else is happening here. So as I said, right here, we do a little trick. What we are doing is we're creating a nested deployment, calling it get AKS managed identity. It will run, it's a cross resource group deployment. So this deployment will run in the scope, that's why I need this version at least, of the node resource group that we defined above. It will run after the VM is created and after AKS is created. So creating it right after the AKS is maybe too soon, and it may actually fail. Giving it a little bit of a delay until after the VM is created helps avoid timing problem when the Azure Managed Application resource provider gets access to this resource group that AKS created. We tell it that we have inner scope for evaluation, and then notice we pass it a parameter called AKS MI resource ID, and the value of this parameter is we go to the AKS cluster, we grab its properties, we grab its identity profile, kubelet identity, and resource ID. So basically, this is in here will be the resource ID of the AKS cluster's identity, and we told it to use the identity of some sort, and this is that identity that we'll need. Why we take it and we pass it to an internal template right here as a parameter, and inside of that template, let's ignore this output, it's kind of not really relevant, but we are outputting back the same resource ID that we passed in, but we are also grabbing the principal ID. That's why we need it. We need this principal ID of that managed identity. This is the latest version of the user assigned identities, properties, principal ID, and we grab it from that resource by reference. So what this does is basically getting the AKS MI when this runs. And again, we are delaying it to run a little later, not right after AKS cluster is deployed, because this resource group may not be fully accessible to us if we run it right away. What do we get next? And like I said, this is really an optional thing. I was just taking a look at what this output looks like. This is the actual role assignment, nested cross-resource group role assignment to the node resource group. So remember how the title of this video said deployment time role assignment. This is basically what is happening. We are doing a nested deployment. We're giving it a unique name, role assignment-GUID. It's running in the scope of the node resource group, okay? And we are saying run this only after identity is ready, AKS is ready, and most importantly, after this ran, right? Because we need the values that are output here. And what we are doing is we are running this, and inside of this template, we have 3 role assignments. And we don't need them for this video, but in the following videos, we will need them. So I'm just showing them right now. So assign owner role to the user assigned identity CrossTenant. So if you remember, we got the role definition ID there. So this is the role definition ID. It's basically subscription ID together with that GUID of a well-known role. We take the identity that we created, the principal ID of that. We say it's a service principal. Managed identity is a service principal. We assign it at the scope of the node resource group. And this is why we needed that well-known name, not the MC underscore generated name, because it would be a little hard to know what is the name where the AKS cluster nodes live. This way, it will be more predictable. And very importantly, this part right here, very important part, this is the delegated managed identity resource ID. We must have this, otherwise these role assignments will not work, because remember, these role assignments get created not by the end customer deploying it, but because this is the template, right, that gets executed by the application managed application resource provider. It is cross-tenant. And this is the special property we need to include when assigning cross-tenant permissions in this way. And over here, we basically, the main thing we do is we pass it the resource ID of that managed identity. The only reason there is this if statement there is because this property can only be used in a cross-tenant scenario. Let's say you wanted to use the same template, easily zip it up and use it in local testing. You would want to hard code a false over here, and then it would not assign this managed identity value. It will just keep null there, so that we can use very similar template. We don't need to comment things out. We just change one parameter, and that's what the if statement is. So don't be confused by the if statement, nothing fancy. Then we assign two more roles in the same way. One role we assign, and notice we need for each role assignment, we need the unique GUID. Role assignments always have a GUID name. So this GUID function creates a unique GUID based on the seed values that I provide. So over here, the seed is based on the node resource group, the identity name, and the role definition owner. Then we need we need a managed identity operator. That's that GUID over here. So this is made up of the node resource group AKMS string and the GUID. And what this permission is, it's assigning it, but notice it's not assigning to the managed identity. It's assigning it to the cluster's principal ID. And we'll see why. For later videos, we'll talk about pod managed identity. This is a way to inject those identities right away. Deployment time, we can always add them later as well in the same way, but it's just as an example. And same one for the virtual machine operator role. So we assign them here too. So basically, that is the overview, the full overview of this template. To understand, you can see it's a little bit complex looking, and this is inside of this repo. It gets zipped up. There is in the README file, example command. So we first want to do a quick validation test, as you remember from other videos. Run the AZ ARM TTK tool against this template. Let's see if it gives us any errors before we publish it in the marketplace. We can see it's complaining that there is an output called managed identity, does not exist in a template. If you remember, we spoke about why it's there. It's this one, and it cannot exist in this template actually. So in this case, we need to ignore this error specifically for this parameter, because this, for managed application, this error kind of is a red herring. It's not the right error. This parameter should not exist in a template. So we ran the validation. It looks good. We create a zip file with our code. Okay, so we're gonna just create a zip file with our code in the right directory. I'm sorry, it's let's say we need to be in the right directory. Create a zip file with our code right there. This was an empty one. Okay, and then we publish it in the marketplace, get into the preview phase. Okay, and once we got it into the preview phase, we can do a quick test. So if we open it up in the preview phase, we're going to deploy the cluster, and in the following videos, we'll take a look at what this cluster is and how it looks. So we're going to say create, and we're going to create our cluster. For example, let's just pick a resource group right here, region, and name of the application and name of the resource group. So let's say like that and like this. And then on the managed identity, it will say on by default. That's what we saw about that UI. Create new. We'll see the pricing of this managed application. Okay. And we'll need to check a box saying we give permission to the publisher and deploy it. Okay. So once we click deploy, this deployment will run, and I'll show you after the deployment what it looks like. So we can see the deployment finished, and we can see the resource that got created, just to show you what does the deployment do. So the deployment, it collected these parameters. And then if you remember, I mentioned that the deployment itself does not really deploy our main template directly. Rather, it creates the application, okay, of kind marketplace, okay, from the plan we have in marketplace. Then it's passing it the managed resource group ID that we specify that parameter, the location, the AKS name, the node size, the node count. These are the parameters that will get fed to our main template. So let's see what got created. So we have the managed application that got created. Let's just take a quick look. It got created in a resource group we defined with the look of how we want it. That's the managed resource group. We have owner access because that's what we did in the publisher portal. We said we want owner access. The identity will be enabled, and this is the managed identity of this managed application. I'm logged in as a customer, so I'm looking at things from customer perspective. And if I click on the Azure role assignments from customer perspective, I can see that the identity of the managed app has contributor access by default to the managed resource group. Great. Let's go to the managed resource group now and see what is there. So let's explore that. So we're going to the managed resource group, and inside of the managed resource group, we see some interesting things. We see our Kubernetes cluster. Okay. We see that managed identity we saw in a template. Okay, we see that log analytics workspace we saw in a template, a storage account we saw in a template, the Bootstrap virtual machine with its NIC, public IP, and VNet, right? So these are the components. The most interesting one for us will be the AKS cluster. But before that, let's take a look at the two deployments that succeeded because it's interesting to understand what was happening there. So first deployment was just creation of this is the creation of that PID for tracking user attribution. And then the second one is the real deployment of multiple things. This is where the deployment was happening. And you can see it created storage account, user identity, workspace, that deployment, virtual network. Then it created a role assignment right here. So let's take a look at what this role assignment did. Let's actually look here in the operation. So this role assignment was assigning permission to this permission to this resource for this deployment. Okay, and then this is basically granting permission to the managed identity. Let's just double check the managed identity and see what assignments it has. And you can see it has the owner assignment to these two resource groups. So that's this assignment over there that we were just taking a look at, right here. That's that role assignment, okay? Then we have NIC. We have the managed cluster creation started. The VM creation started after the cluster because with dependency. Then we have that get AKMS. And let's see what's happening inside of here. We gave it, if you remember in the template, the resource ID parameter. So just going back to the template to make it very concrete and clear, because it is a little tricky here. So let's say inside of here we pass the parameter. So the value of this parameter was the kubelet identity resource ID, and this is basically what it is. And the output was echoing back the same thing, that environment thing that we don't care about. But more importantly is this principal ID of this resource ID. Okay, so that was important. And this is that nested deployment. And if we look at the nested deployment, you can see that there's three assignments here. And this is the assignment for principal ID of the managed identity. And this is two assignments for principal ID, see the same, of the cluster identity. Again, the same one we saw right here, okay? So that's what's happening. Again, in the template, it corresponds to this section of assigning cross-resource group deployments assignments. So that answers how that is done. And we needed a delay. Again, why do we need a delay? Because remember, when an AKS cluster is deployed, it creates an AKS cluster resource group, the one we discussed here. The managed application resource provider doesn't get access to this resource group immediately, and it needs access to be able to grant proper permissions, like we were trying to assign them there. So we need to wait a little bit, and that's why I made it so that the AKS cluster deploys first, VM deploys second, and then the assignments happen after the VM deployment. Okay, so there could be a timing issue without this. Great. Now this is that deployment, and let's see what are the resource groups that we created. So you can see we have 3 resource groups in play. This is the resource group inside of which, so let's filter this out for analysis here. Okay, so we have a resource group that has the app inside. Again, going back to our picture is this one. We have a resource group I called MRG with the app name. This is the Managed Application Resource Group with the Kubernetes cluster. That's this one. And then we have one more resource group, MRG-AKSRG. Where is that name came from? That's because in this template, the variable name right here is adding AKSRG to the name of the managed resource group. And this is used inside, as we discussed, right over here in the managed cluster creation. It's using this for storing the nodes, so it's well-known name. And that is where we see the VM scale sets and other things. Remember, that's that managed identity of the cluster itself, for which we assign permission. So take a look from customer side, things look like this. Under access control, I can see that the contributor access is given to the managed identity of the app. The managed identity operator is granted a deployment time using that nested deployment. Okay. Then the owner permission is granted to our identity we created inside of this resource group. And one more permission is granted for later to the AKS cluster's agent pool role for VM machine contributor. So we see all these roles were assigned. Okay, let's look at deny assignments, and this will be the end of this video. You can see under deny assignments, which we discussed at length in the first couple of videos, for the second video, you can see deny assignment is added. So me as a customer, I'm denied of making changes here to this resource group, which makes sense. How can I confirm it? Well, if we go to the resource group and we try to do something like adding tags, for example, we're going to get a failure because of the access is denied, right? And we cannot change AKS cluster, let's say scale, right? Let's say we go to scale and we want to scale. You can see this is disabled because I'm a customer, I'm logged in here. I don't have access to change the resources in this resource group since it's managed. Here is going to be now the challenge that I was mentioning before. Let's go to this resource group where the Kubernetes cluster is running. Okay, let's look at deny assignments. I'm still in the customer. And you can see there are no deny assignments. So this is what we discussed right over here in this picture, that the deny assignments for the customer are not added. And today I have read and write access. How can we confirm that? Well, if we go to the overview of this group, I can definitely add tags if I wanted to. It will work for me to add tags, even though I'm a customer and this is kind of part of the managed application. So that's a little bit dangerous, obviously, as we discussed. And what I can also do is I can scale this VM scale set, for example, and save it and do stuff, even though I cannot do it at the parent level. So that is the key point I wanted to make, to just call home, to bring it all back, to explain this picture more. This is locked, this is not locked. But on the publisher side, let's see. So in this window, I'm logged in as the publisher, and you can see the publisher is able to see in the Managed Application Center, I searched for it here, that there is a customer that deployed this, this application. You can see which the name of the application, which resource group it is in. So you can see the publisher is seeing this, and the publisher is able to do changes to this resource group without problem. You can see scaling is possible on the publisher side. Let's double check. So if I go to scale, actually it disables this because it supports multiple pools. I should have showed it here. Go to node pools, click on node pool, and you can see that the publisher is able to change and save. So let me make a change and save. So I'm a publisher, I'm making a change. And if we just double check again that I did not make a mistake on the customer side, I only looked at scale here and I saw it's disabled, but that doesn't mean anything. We need to look right here, and if we make a change, we should see the error from the customer side. So the publisher is able to see this resource group and make changes to it as need be, and the publisher is also able to see the resource group where the other nodes are, which is great. And let's go and double check that we can remove the tag we added. Maybe I already removed the tag I added. Let's remove and save. So the publisher is able, again, to access both. Publisher is able to access, read, write both of these resource groups. So they have enough control. So that's hopefully gives a pretty detailed view of how to make a template that deploys AKS cluster inside of a managed application. It's a simple AKS cluster, and then inside of the same template do some tricky assignments cross resource groups using this special property. Just remember that when deploying it locally, you will want to send the CrossTenant to false. And these deployments exist. In the next videos, we're going to go more into the managed identity on the nodes in this cluster and see how things work there. Thank you for watching.